Hey there, mystery lovers. Today we're taking a trip down the rabbit hole of ancient WTF moments. You know, the kind of stuff that makes archaeologists stare at their coffee, wondering if they chose the wrong career. We're talking about temples that shouldn't exist, computers from 100 BC, and rocks that apparently learned how to walk. The kind of mysteries that make even the smartest scientists throw their hands up and go, "Yeah, I got nothing." These aren't your typical unsolved cases. These are the artifacts and structures that straight up mock our understanding of human history. So before we dive into this journey of ancient head-scratchers, smash that like button if you're ready to question everything you thought you knew about our ancestors. And hey, drop a comment. Where in the world are you watching from? I want to know who's joining me on this wild ride through humanity's greatest "how did they do that" moments. Ready to have your mind properly blown? Let's get into it. Let's kick things off with arguably the most mind-bending discovery in archaeological history, and trust me, that's saying something. Picture this. It's 1901, and a bunch of Greek sponge divers are doing their thing off the coast of the tiny island of Antikythera, minding their own business, probably not expecting to stumble upon anything more exciting than some decent seafood. Instead, they find a Roman shipwreck absolutely loaded with bronze statues, pottery, and various ancient treasures. Cool find, right? Except buried among all that standard ancient loot was something that would make archaeologists lose their collective minds for the next century and counting. At first glance, it looked like a corroded lump of bronze and wood. Basically fancy ancient trash. The kind of thing you'd walk past in a museum without a second thought, maybe snap a quick photo if you're really into oxidized metal. The divers hauled it up along with everything else, and for a while this unassuming chunk of corroded whatever sat in storage at the National Archaeological Museum in Athens, probably feeling pretty ignored while the fancy statues got all the attention. Naturally, because who gets excited about a crusty rock when there are pristine marble gods standing around looking photogenic? But then someone actually took a closer look at this crusty rock, and that's when things got properly weird. Turns out this wasn't just any old piece of corroded bronze. This thing had gears, like actual mechanical gears. Dozens of them, all precisely cut and interlocking, hidden inside what looked like a wooden case that had seen better days, specifically about 2000 better days. We're talking about a device from around 100 BC, give or take a few decades, featuring technology that supposedly wouldn't exist again until medieval European clockmakers finally figured out how gears worked. Which, if you're keeping score, means this thing was about 1,000 years ahead of its time. No big deal. Just a casual millennium-long technology gap. Move along, nothing to see here. Now, when I say this device had gears, I'm not talking about a couple of rough circles with some teeth carved into them. We're talking about at least 30 bronze gears, probably more that got lost to time and the ocean floor, all working together in a complex system that would make a Swiss watchmaker weep with envy. The precision on these things is absolutely bonkers. We're talking gears with teeth cut so accurately that they could track the movements of celestial bodies across the sky. In 100 BC. When most people thought the gods were literally pulling the sun across the sky with a chariot, someone was out here building what's essentially an ancient astronomical computer. Talk about being ahead of the curve. So what exactly did this contraption do? Well, buckle up, because this is where it gets really fun. The Antikythera mechanism, as it's now dramatically called, was basically an ancient Greek calculator designed to predict astronomical positions and eclipses decades in advance. You'd turn a crank on the side, unfortunately that Bluetooth connectivity and touchscreen interface hadn't been invented yet, and the gears would whir around, calculating the positions of the sun, moon and planets with frightening accuracy. It could predict solar and lunar eclipses, track the Olympic Games cycle, and even account for the irregular orbit of the moon. You know, casual stuff that scientists wouldn't fully understand until the 20th century rolled around with actual computers to help them out. The level of astronomical knowledge required to build this thing is staggering. Whoever designed the Antikythera mechanism had to understand that the moon's orbit wasn't a perfect circle, which is something that even professional astronomers struggled with for centuries. They had to know the precise length of the solar year, the lunar month, and how to calculate when eclipses would occur. They had to understand gear ratios, mechanical engineering, and bronze casting techniques sophisticated enough to create perfectly interlocking components. And they had to do all of this without the benefit of, electricity, precision measurement tools, or the ability to just Google how to build ancient computer when they got stuck. Here's where it gets even more ridiculous. The device had inscriptions all over it, basically an ancient instruction manual scratched into the bronze, because apparently whoever built this knew that finding it 2,000 years later would be confusing enough without any documentation. Unfortunately for us, most of those inscriptions are about as readable as a prescription written by a doctor who's late for lunch, thanks to centuries of corrosion and general underwater deterioration. But from what researchers have been able to decipher, the instructions include astronomical calculations, eclipse predictions, and information about various Greek calendars. It's like finding an iPhone from 100 BC, except even more confusing because at least we understand how iPhones work. Mostly. Modern scientists have been absolutely obsessed with this thing for over a century now, and honestly, who can blame them? Teams of researchers have used X-ray technology, CT scans, and 3D modelling to try to understand how it worked and what it could do. Each new scan reveals more hidden gears, more inscriptions, more evidence that whoever built this thing was operating on a completely different level from everyone else in the ancient world. It's like discovering that your great-great-great-great-grandparents had a laptop. Sure, it doesn't have Wi-Fi, but the fact that it exists at all is enough to make you question everything you thought you knew about history. The real kicker? We have absolutely no idea who built it. Zero. Zilch. Complete historical radio silence on this front. There are theories, of course, because historians love a good theory. Some researchers think it might have been created by the brilliant astronomer Hipparchus, who lived around the right time and was definitely smart enough to pull off something this complex. Others point to Archimedes, the legendary mathematician and inventor who was famous for creating all sorts of wild mechanical devices before the Romans rudely interrupted his work by, killing him during the siege of Syracuse. There are ancient references to similar devices. Cicero mentions a bronze sphere created by Archimedes that could show the movements of the sun, moon, and planets. But whether the Antikythera mechanism was built by one of these famous geniuses or some unknown craftsman who deserved way more recognition than they got, we'll probably never know for sure. What we do know is that this wasn't a one-off weird experiment. The device was too sophisticated, too well designed to be someone's first attempt at mechanical engineering. The precision and complexity suggests that there was a whole tradition of making these kinds of astronomical calculators in the ancient Greek world, which means there were probably other devices like this floating around. Maybe sitting in rich people's homes, maybe being used by professional astronomers, maybe decorating temples. But here's the depressing part. If there were others, they're all gone. Lost to time, melted down for their bronze, destroyed in wars, or just plain forgotten when the knowledge of how to make them disappeared along with the civilization that created them. And that's really the most frustrating part of the whole Antikythera mechanism story. This device represents a level of technological sophistication that we didn't think existed in the ancient world, and it raises some seriously uncomfortable questions about what else we've lost. If the ancient Greeks could build mechanical computers 2,000 years ago, what other technology did they have that we don't know about? What other innovations disappeared when libraries burned, cities fell, and knowledge was scattered to the winds? It's like finding one page from an advanced physics textbook in a medieval monastery and realizing you have no idea what else was in that book or where the rest of it went. The technology to create something like the Antikythera mechanism didn't show up again until the 14th century, when European clockmakers started building astronomical clocks in cathedral towers. That's a gap of roughly 1,400 years. 14 centuries where this kind of mechanical sophistication apparently just vanished from human knowledge. Sure, other civilizations were doing their own impressive things during that time. The Islamic world was making huge strides in mathematics and astronomy. China was inventing everything from printing to gunpowder, and everyone was generally keeping busy. But the specific technology demonstrated by the Antikythera mechanism? Gone. Lost in the great historical data purge that happened when the classical world collapsed. Modern attempts to recreate the device have been both illuminating and humbling. Engineers and craftsmen using traditional techniques, hand tools, bronze casting, no power drills or CNC machines, have managed to build working replicas. But it takes months of painstaking work by people who understand ancient metalworking and have studied the original extensively. Now imagine building one of these from scratch, without the benefit of examining the original, without modern measurement tools and doing it all while living in a world where the cutting edge of technology is, we figured out how to make really good pottery. The level of genius required is almost incomprehensible. What's particularly wild is that this mechanism wasn't even trying to look impressive. It wasn't a showpiece designed to wow people with obvious complexity. It was packed into a wooden case, probably about the size of a shoebox with the gears hidden inside. Only the dials would have been visible on the outside, showing the astronomical positions and predictions. It was a practical tool, designed to actually be used, not just displayed. Which raises another question. If this was a working tool rather than a fancy display piece, how common were these things? Was there a whole industry of ancient astronomical computer makers that we know nothing about? Were there workshops in Athens or Alexandria cranking these out for wealthy clients who wanted to impress their dinner guests by accurately predicting the next lunar eclipse? The shipwreck where the mechanism was found adds another layer of intrigue to the whole story. The ship was carrying a cargo of luxury goods, bronze statues, glass vessels, fine pottery, suggesting it was probably heading from the eastern Mediterranean to Rome, possibly carrying loot from some Greek city. The Antikythera mechanism was travelling with all this other valuable stuff, which tells us it was considered precious enough to transport carefully. But was it being sold as a curiosity, given as a diplomatic gift? Stolen from a temple or wealthy household? Was it even the only one on the ship, or were there others that got scattered across the ocean floor and buried under silt where we'll never find them? The possibilities are endless and equally frustrating. Here's what really gets me about this whole thing. The Antikythera mechanism sat in that museum for months before anyone realised what it was. Archaeologists walked past it, probably dozens of times, thinking it was just another piece of corroded scrap metal from the shipwreck. It took someone with enough curiosity and persistence to look closer, to notice that the patterns on the surface weren't just random corrosion, but actual mechanical components. How many other artifacts are sitting in museum storage rooms right now, looking like unremarkable junk, that might turn out to be equally revolutionary if someone just took the time to really examine them? How many pieces of ancient technology have we already excavated and then categorized as random bronze fragments, because we weren't looking closely enough? The Antikythera mechanism forces us to confront an uncomfortable truth about our understanding of history. We don't know nearly as much as we think we do. We like to imagine a nice, neat progression of technological development, with primitive ancient people slowly figuring things out until we finally arrived at our modern advanced civilization. But here's physical proof that sometimes ancient people were doing things that seem impossible for their time period. They were building complex machines, understanding advanced mathematics, and creating technology that wouldn't be matched for over a millennium, and then that knowledge just vanished, leaving us to rediscover it all over again centuries later. The really scary thought: the Antikythera mechanism might not even be the most impressive thing the ancient Greeks built. It's just the only one that happened to survive 2,000 years at the bottom of the ocean and get lucky enough to be found by modern archaeologists. There could have been devices that made this one look like a simple calculator. Advanced machines for all sorts of purposes, mathematical calculations, engineering designs, architectural planning, that we'll never know about because they all got melted down or destroyed or lost. We're looking at what might be just the tip of a technological iceberg that mostly sank into historical obscurity. So the next time someone tells you that ancient people were primitive and couldn't possibly have understood complex concepts, just remember that somewhere around 100 BC, while most of the Mediterranean world was concerned with basic survival and political drama, someone was sitting in a workshop handcrafting bronze gears accurate enough to predict eclipses decades into the future. Someone was doing calculations that would make modern astronomers nod in respect. Someone was building a mechanical computer that would remain unmatched for 1,400 years, and we don't even know their name. That's the real mystery of the Antikythera mechanism, not just how it was built, but how many other brilliant innovations we've lost along the way, and what else might still be out there waiting to be discovered. Now, if you thought the Antikythera mechanism was a brain melter, buckle up, because we're about to talk about a discovery that literally forced archaeologists to rewrite the entire timeline of human civilization. I'm talking about Göbekli Tepe, a massive temple complex in southeastern Turkey that has been sitting on a hilltop for over 11,000 years, basically giving the middle finger to everything we thought we knew about prehistoric humans. This place is so old that it makes the Egyptian pyramids look like last week's construction project. The pyramids? Those are practically modern architecture compared to this prehistoric masterpiece. Here's what makes Göbekli Tepe absolutely bonkers. It was built around 9,600 BC by hunter-gatherers. Let me repeat that for the people in the back: hunter-gatherers. You know, the folks who are supposedly running around in animal skins, living in caves, and whose biggest technological achievement was figuring out that pointy sticks were good for hunting. These were people who hadn't invented farming yet, who didn't have permanent settlements, who were literally still figuring out the whole "maybe we should stop wandering around and settle down somewhere" concept. And yet somehow, some way, these supposedly primitive nomads decided to build a massive ceremonial complex with carved stone pillars, intricate reliefs, and architectural sophistication that shouldn't have existed for another 5,000 years. No big deal, just casually defying the entire archaeological timeline. The site was discovered in 1963 by a team of archaeologists from the University of Chicago and Istanbul University. But here's the kicker: they completely misidentified it as just another medieval cemetery and moved on. Imagine being that archaeologist who walked away from potentially the most significant archaeological discovery of the 20th century because you thought it was just some boring old graveyard. That's got to sting. It wasn't until 1994 that a German archaeologist named Klaus Schmidt took another look at the site and basically had his mind blown into orbit. Schmidt immediately recognised that the limestone fragments scattered across the hilltop weren't medieval grave markers at all. They were the tops of massive buried T-shaped pillars. And when excavations began, oh boy, did things get interesting. What they found underneath that Turkish hilltop was nothing short of revolutionary. We're talking about multiple circular enclosures, each one containing massive T-shaped limestone pillars arranged in rings. These aren't your average rocks either. Some of these pillars weigh up to 50 tons. That's about the weight of 7 African elephants, for reference. And they're carved with incredibly detailed reliefs of animals. We've got foxes, lions, bulls, scorpions, snakes, birds, and even some creatures that archaeologists still can't quite identify. The level of artistic skill is extraordinary, especially considering these were carved by people who supposedly spent most of their time just trying to not starve to death. The carvings are sophisticated, stylized, and executed with a level of precision that suggests these weren't amateur doodles scratched into stone during someone's lunch break. But wait, it gets even more ridiculous. The pillars themselves are engineering marvels. Each one had to be quarried from the surrounding limestone bedrock, shaped into that distinctive T-shape, transported to the construction site, and then erected perfectly upright. And we're not talking about moving a few dozen of these things. Current excavations have revealed dozens of pillars across multiple enclosures, and ground-penetrating radar suggests there could be hundreds more still buried. All of this was accomplished without metal tools, without wheels, without pack animals, and without any of the technological advantages that you'd think would be absolutely necessary for this kind of massive construction project. It's like showing up to a Formula One race with a skateboard and somehow winning. The organisation required to build Göbekli Tepe is mind-boggling when you actually stop and think about it. This wasn't the work of a few people messing around with rocks on weekends. Estimates suggest that moving just one of those 50-ton pillars would have required at least 500 people working together. 500 people. In a society that supposedly consisted of small nomadic bands of maybe 20 to 30 individuals wandering around hunting gazelles and gathering wild plants. Where did these people come from? How did they coordinate? How did they feed themselves while building this thing? Were they taking turns, showing up for construction season like some kind of prehistoric timeshare arrangement? The logistics alone are staggering, and that's before we even get into the question of why they built it in the first place. Because here's the thing that really keeps archaeologists up at night. We have absolutely no idea what Göbekli Tepe was actually for. There's no evidence of permanent habitation at the site, no houses, no signs of daily domestic life. It was purely ceremonial, which means people were travelling to this location specifically to do whatever religious or ritual activities they were doing there, and then leaving again. The sheer amount of effort that went into creating a space that wasn't even used for practical living purposes suggests that whatever was happening at Göbekli Tepe was seriously important to these people. Important enough to coordinate massive labour efforts across multiple nomadic groups, important enough to develop quarrying and construction techniques that they had no business possessing, important enough to create what might be humanity's first true architectural monument. And if that wasn't mysterious enough, here's where the story takes an even weirder turn. Around 8000 BC, after using the site for roughly 1,500 years, the people of Göbekli Tepe deliberately buried the entire complex. They didn't abandon it or let it fall into ruin naturally. They intentionally filled in all the enclosures with dirt and debris, carefully covering up their monumental achievement and essentially hiding it from history. Why? Nobody knows. Maybe the religious significance changed and it became taboo. Maybe there was some kind of cultural shift or upheaval. Maybe they just got really into feng shui and decided the whole hilltop temple vibe wasn't working for them anymore. The fact that they took the time and effort to properly bury everything rather than just walking away suggests this was a purposeful, meaningful act. But what that meaning was? Your guess is as good as mine, and mine is about as good as the experts' guesses, which is to say, not very good at all. The discovery of Göbekli Tepe has fundamentally challenged one of archaeology's most sacred assumptions about how human civilization developed. The traditional narrative went something like this. First, humans figured out agriculture, which led to food surpluses, which allowed people to settle in one place, which led to population growth, which created the need for social organization, which eventually resulted in religion, art, and monumental architecture. Nice, clean, linear progression. Agriculture comes first, civilization follows, except Göbekli Tepe flips that entire sequence on its head. Here we have monumental architecture, sophisticated art, and complex social organization appearing thousands of years before agriculture. These people built massive temples before they built permanent houses. They organized large-scale construction projects before they figured out how to plant seeds. It's like deciding to build a cathedral before you've invented the village. This has led some researchers to propose a fascinating theory. What if religion came first? What if the need to create sacred spaces and gather for ritual purposes is actually what drove humans to develop agriculture and settle down, rather than the other way around? Maybe Göbekli Tepe wasn't built by an already settled agricultural society. Maybe Göbekli Tepe is why people settled down and became agricultural in the first place. The need to maintain and use this ceremonial centre might have prompted people to stick around the area rather than following their traditional nomadic patterns. And if you're going to stay in one place for extended periods, well, you might as well figure out how to grow your own food instead of constantly hunting for it. Suddenly agriculture becomes not the cause of civilization, but a consequence of humans' desire to build impressive religious monuments, which is either brilliantly insightful or completely backwards, depending on which archaeologist you ask. The implications of Göbekli Tepe extend far beyond just one site in Turkey. If hunter-gatherers 11,000 years ago were capable of this level of organization and construction, what else were they capable of that we don't know about? How many other monumental sites from this period are still buried and undiscovered? We know that only about 5% of Göbekli Tepe itself has been excavated so far. The rest is still underground, waiting to reveal who knows what additional surprises. And Göbekli Tepe isn't even unique anymore. Archaeologists have since found other similar sites in the region, like Karahan Tepe and Harbetsuvan Tepesi, all dating to roughly the same period. This suggests there was a whole culture of prehistoric monument building that we're only just beginning to understand. A culture that existed in that supposed dark age before civilization, when humans were allegedly too busy surviving to create anything impressive. What's particularly humbling about Göbekli Tepe is how it was sitting there the whole time, just waiting to be properly recognized. That hilltop has been known to locals for generations. Farmers ploughed around the limestone fragments for years, probably cursing whoever left all these rocks scattered across their fields. The site was literally in plain sight, documented by archaeologists in the 1960s, and yet it took until 1994 for someone to actually recognize what it was. It makes you wonder how many other revolutionary discoveries are out there right now, hiding in plain sight, waiting for someone to look at them with fresh eyes and realize their true significance. How many supposedly unremarkable hills are actually covering prehistoric temples? How many natural rock formations are actually ancient structures so old that nature has reclaimed them? The symbolism carved into the pillars at Göbekli Tepe adds another layer of mystery to the whole situation. The animals depicted aren't random. They seem to follow specific patterns and possibly represent some kind of symbolic or religious meaning. Some pillars feature multiple species interacting in ways that might tell a story or convey a message. There are abstract symbols too, geometric shapes and patterns that might be early forms of writing or numerical systems, though that's pure speculation at this point. Archaeologists have found evidence of feasting at the site, massive quantities of animal bones suggesting large gatherings where people consumed significant amounts of meat. Were these ritual feasts, celebrations, sacrifices, social bonding exercises for different nomadic groups, all of the above? The archaeological record is frustratingly silent on these details. Klaus Schmidt, who led excavations at Göbekli Tepe until his death in 2014, spent 2 decades of his life trying to understand this place, and even he admitted that every answer they found just raised 10 more questions. He called it a cathedral on a hill, which is apt. It clearly served some profound religious or ceremonial purpose that drew people from potentially hundreds of miles around. But unlike later temples and religious sites, we have no texts, no inscriptions, no handy explanatory plaques left by the builders telling us what they were thinking. We're left to piece together meaning from stone carvings, architectural layouts, and the spatial distribution of bones and artifacts. It's like trying to understand modern Christianity by examining only the architecture of medieval cathedrals, while having absolutely no access to the Bible, prayer books, or any written records whatsoever. Possible, maybe. Accurate, probably not. If Göbekli Tepe made you question what prehistoric humans were capable of, then welcome to Baalbek, where we're going to question what the Romans were capable of, what came before them, and whether the laws of physics were just suggestions in the ancient world. Located in modern-day Lebanon, Baalbek is home to some of the largest worked stone blocks ever used in construction anywhere on Earth. And when I say large, I don't mean impressively big. I mean stupidly, absurdly, impossibly massive. We're talking stones that make modern engineers look at their cranes and calculators and just start crying. Let's start with the absolute unit of the Baalbek stones, the one that makes all the other massive stones feel inadequate about their size. It's called the Stone of the Pregnant Woman, which is frankly an insult to its magnificence, but we're stuck with that name now because archaeologists apparently have the worst naming conventions in academic history. This single limestone block weighs approximately 1,650 tons. That's 3.3 million pounds. That's roughly equivalent to the weight of 3 Statue of Liberties, or 15 blue whales, or 300 African elephants. Pick your preferred unit of measurement for absolutely ridiculous weight, and this stone qualifies. And here's the really fun part. It's just lying in the quarry where it was carved, probably because even the ancient builders looked at it and thought, you know what, maybe we got a bit too ambitious with this one. But wait, because it gets better. The Stone of the Pregnant Woman isn't even the biggest stone at Baalbek anymore. In 2014, archaeologists discovered an even larger block in the same quarry, weighing an estimated 1,800 tons. This thing is so big that it doesn't have a cute nickname yet. It's just that other absolutely massive stone that makes engineers cry. And both of these monster blocks were apparently cut and shaped with the intention of using them in construction. Which raises the obvious question, what were these people thinking? What kind of construction project requires stones that weigh as much as a naval destroyer? Were they building a temple or preparing to anchor a continent? Now you might be thinking, okay, sure, they carved some really big rocks and then realized they couldn't move them. Big deal. But here's where things get properly insane. They actually did successfully move and install stones that were almost as massive. The foundation of the Temple of Jupiter at Baalbek contains what are called the trilithon, 3 absolutely enormous limestone blocks, each one weighing around 800 tons. That's still heavier than anything we would consider moving with modern equipment without serious planning and specialized machinery. These blocks are positioned about 20 feet above ground level in the western wall of the temple complex, fitted together with such precision that you literally cannot slide a piece of paper between them. The joints are so tight, the alignment so perfect, that it looks like someone just 3D printed these multi-hundred-ton stones directly into place. The Romans, who built the Temple of Jupiter at Baalbek, were absolute masters of engineering. These were the people who built the Colosseum, the Pantheon, aqueducts that still work 2,000 years later, and roads so well constructed that some are still in use today. Roman engineering was no joke. They understood arches, concrete, hydraulics, and large-scale construction like nobody's business. But here's the problem. Even the Romans, with all their engineering genius and organizational skills, didn't have the technology to move 800-ton stones. Their largest cranes could handle maybe 100 tons under ideal conditions. Moving an 800-ton block would require equipment that simply didn't exist in the Roman engineering toolbox. It's like finding out that medieval monks built the International Space Station using only prayer and determination. This has led to a fascinating debate among archaeologists and engineers about who actually put those foundation stones in place. The popular theory is that the Romans built on top of an earlier structure, incorporating these massive blocks that had been placed there by whoever came before them. But if it wasn't the Romans, then who? The Phoenicians who inhabited the area before Roman conquest? The Bronze Age civilizations that predated them? Some even earlier culture that we barely know anything about? The problem is that the older you go in history, the less sophisticated the technology supposedly gets, which makes the mystery even more confusing. It's like assuming your great-great-grandparents had a better smartphone than you do. Let's talk about the logistics of moving these blocks, because it's truly mind-boggling. First, you have to quarry them from the limestone bedrock, which means carefully cutting away hundreds of tons of stone without causing cracks or breaks. The quarry is about 3/4 of a mile from the temple site, which might not sound like much, but when you're moving something that weighs 800 tons, every foot is an engineering nightmare. The route includes uphill sections and areas where the ground would need to be carefully prepared to support that kind of weight. Modern engineers have calculated that moving just one of these blocks would require at least 40,000 people pulling in coordinated fashion, or some kind of rolling mechanism that would have to be constructed specifically for this purpose. And remember, they moved 3 of them, positioned them precisely at an elevated height, and made them fit together perfectly. No pressure. Some researchers have proposed that the stones were moved using a combination of rollers, ramps, and lubrication, essentially turning the transport route into a giant slip and slide for multi-hundred-ton rocks. Others suggest sophisticated lever systems or even some kind of advanced machinery that we have no archaeological evidence for but would explain a lot if it existed. There's even a fringe theory involving acoustic levitation, using sound waves to reduce the effective weight of the stones, which is probably nonsense but at least gets points for creativity. The honest truth is that nobody really knows how they did it, and the gap between what we know ancient technology was capable of and what would be required to move these stones is uncomfortably wide. Modern attempts to replicate moving stones of this size have been humbling exercises in failure. In 2014, a team of engineers tried to move a 340-ton replica block using techniques that might have been available to ancient builders. They managed to slide it a few feet before encountering problems with ground stability and control. 340 tons, less than half the weight of the trilithon blocks, and modern engineers with detailed planning, modern materials for rollers and levers, and complete knowledge of physics struggled to move it even a short distance. Now imagine doing that with 800-ton blocks, over rough terrain, elevated to a height of 20 feet, and fitting them together with watchmaker precision. Suddenly the whole thing seems less like history and more like a physics-defying magic trick. The precision of the stonework at Baalbek is arguably even more impressive than the size of the stones. When you're working with blocks this massive, any mistake is catastrophic. You can't just say oops and try again when your stone weighs more than 600 elephants. The blocks would have to be shaped and finished before placement, because there's no way to do detail work once they're installed. And yet the fit is absolutely perfect. The joints between the trilithon blocks are so tight that modern masons look at them and shake their heads in disbelief. This level of precision requires not just skilled craftsmanship but also incredibly accurate measurement and planning. You'd need to know exactly how big each stone was, exactly where it was going, and exactly how it would fit with its neighbours before you even started moving it. One miscalculation, and you've got an 800-ton paperweight that's in the wrong spot. What makes Baalbek even more mysterious is that we don't really know why anyone would want to use stones this large in the first place. Sure, they're impressive, and they certainly make a statement about the power and capabilities of whoever built the structure. But from a purely practical engineering standpoint, using smaller stones would be infinitely easier and achieve essentially the same result. You could build an equally stable, equally impressive structure with blocks weighing only 10 or 20 tons, which are still massive but at least theoretically movable with ancient technology. So why go through the incredible effort of using 800-ton blocks when it wasn't strictly necessary? Was it a deliberate display of power, a religious requirement, a technological flex? An engineering challenge that someone accepted just to prove it could be done? We're left guessing. The Temple of Jupiter that sits atop these massive foundation stones was itself one of the largest temple complexes in the Roman Empire. The temple proper featured massive columns over 60 feet tall, intricate decorations, and a grand scale that was meant to inspire awe. But even the impressive Roman construction looks almost modest compared to those foundation stones. It's like building a beautiful modern house on top of the foundations of an ancient fortress. Sure, your house is nice, but those foundations make you wonder what kind of structure they were originally meant to support. Were the massive stones part of an earlier, even more ambitious construction project? Did the Romans simply incorporate them because they were already there and moving them would have been more trouble than it was worth? The archaeological record doesn't give us clear answers. Local legends add another dimension to the Baalbek mystery. According to some traditional stories, the foundation stones were laid by giants or supernatural beings, which is honestly as good an explanation as any given that the engineering involved seems genuinely superhuman. Other legends claim that the site was sacred long before the Romans arrived, possibly dating back thousands of years to Bronze Age or even earlier civilizations. While we can dismiss the giants theory, probably, the idea that Baalbek was a sacred site with a long pre-Roman history isn't actually that far-fetched. The location has excellent water sources, strategic positioning, and natural resources that would have made it attractive to human settlement for millennia. Modern scanning technology has revealed that there might be even more to Baalbek than what's visible on the surface. Ground-penetrating radar and other non-invasive techniques have detected what appear to be additional chambers, passages, and structures beneath the temple complex that haven't been fully excavated yet. Each new discovery tends to raise more questions than it answers. Did the site serve multiple purposes over thousands of years? Were there earlier temples or structures on the same location? What's buried under the Roman construction that we haven't found yet? Archaeology is frustratingly slow, especially when you're dealing with a site that's been continuously inhabited and modified for potentially 6,000 years or more. The biggest stones at Baalbek force us to confront an uncomfortable possibility. Maybe ancient civilizations were capable of things that we still can't fully explain or replicate. We like to think of technological progress as linear, with each generation building on the knowledge of the previous one, always moving forward. But what if knowledge was lost? What if there were techniques, methods, or technologies that disappeared when civilizations fell, libraries burned, or oral traditions died out? The Baalbek stones are physical evidence that someone somewhere at some point in history figured out how to work with stone at a scale that seems impossible even by modern standards. And then that knowledge apparently vanished, leaving us to stand in front of these massive blocks scratching our heads and wondering how the hell they did it. The site continues to attract researchers, engineers, and anyone with an interest in ancient mysteries, all trying to solve the puzzle of how these impossible stones were quarried, moved, and placed with such precision. Someday, maybe we'll figure it out definitively. Maybe some brilliant engineer will recreate the methods used, or maybe archaeologists will find some ancient documentation that explains the whole process step by step. But until then, Baalbek stands as a monument to the fact that ancient people could accomplish things that still seem impossible thousands of years later. And maybe that's the real lesson here, that we shouldn't underestimate what human beings can achieve when they're properly motivated, even if we can't quite figure out how they pulled it off. Just when you thought we'd covered all the ways ancient people could make modern archaeologists question their life choices, let me introduce you to the Nazca Lines. Imagine taking a perfectly good desert in Peru and deciding you know what this needs. Absolutely massive drawings of animals and geometric shapes that are only properly visible from hundreds of feet in the air. Now imagine doing this between 500 BC and 500 AD, when the cutting edge of aviation technology was throw a rock really hard and hope for the best. The Nazca people looked at their arid plateau and thought, we're going to create art for an audience that won't exist for another 1,500 years, and you thought your long-term planning was ambitious. The Nazca Lines cover an area of about 170 square miles in the Peruvian coastal desert, and they're not just a few casual doodles scratched into the dirt. We're talking about over 800 straight lines, 300 geometric figures, and 70 animal and plant designs, some of which stretch up to 1,200 feet across. That's longer than 4 football fields for reference. There are hummingbirds the size of actual houses, spiders with legs that go on forever, monkeys, condors, fish, and various other creatures rendered with such precision and style that you'd think someone was up in a hot air balloon directing traffic. Except, plot twist, they absolutely were not. The creation method was surprisingly straightforward, which somehow makes the whole thing even more impressive. The Nazca Desert has this dark reddish-brown layer of pebbles on top, and underneath there's lighter-coloured sand. So the Nazca people simply removed the top layer of rocks to reveal the lighter ground beneath, creating these massive drawings through careful excavation. No fancy tools required, just a whole lot of patience, some stakes and ropes for making straight lines, and presumably a very, very detailed plan. The dry climate of the region has preserved these lines for over 2,000 years, because apparently even the weather looked at this achievement and decided it deserved to stick around. But here's where things get genuinely puzzling. You cannot see these designs properly from ground level. If you're standing next to the Nazca hummingbird, all you see is a bunch of cleared paths going in seemingly random directions. It's only when you get a few hundred feet up in the air that the shapes become recognizable. So why on earth would you spend years, possibly generations, creating massive artworks that you can't even appreciate from ground level? It's like painting the ceiling of the Sistine Chapel in a room with a 3-foot ceiling. Sure, it's there, but who's it for? The most famous theory, popularized by researcher Maria Riker, who dedicated her entire life to studying and preserving these lines, is that they served as some kind of astronomical calendar. Riker spent decades mapping the lines, living in a small house near the desert, basically making the Nazca lines her full-time obsession. She proposed that some of the lines aligned with solstices, equinoxes, and the rising and setting points of various stars. The idea being that the Nazca people used these massive desert drawings to track celestial events important for agriculture and religious ceremonies. Which is certainly possible, though it does raise the question of whether you really need a 900-foot-long spider to tell you when planting season starts. Seems like overkill, but maybe that's just me. Other researchers have suggested the lines were walking paths for religious processions, with people following the animal figures as part of ritual ceremonies. This would at least explain why they bothered making them. If you're going to walk in a sacred pattern, you might as well make that pattern represent something meaningful, even if the full picture is only visible to the gods looking down from above. The Nazca culture was deeply religious, and water was sacred in this dry region, so some theories propose that the lines were offerings to sky deities who controlled rain. Essentially, hey sky gods, check out this absolutely massive monkey we drew for you. Rain would be appreciated. Thanks in advance. Then there are the straight lines, which are honestly even more bizarre than the animal figures. Some of these lines run perfectly straight for miles, cutting across hills and valleys without deviation. We're talking about lines that maintain their direction with such accuracy that they look like someone used a laser level, except laser levels wouldn't exist for another 2,000 years. The longest of these lines stretches for over 30 miles in an almost perfectly straight path. 30 miles, without GPS, without surveying equipment, without any way to see more than a few hundred yards ahead in any direction. How do you even plan something like that? Did they have relay teams with flags, smoke signals, extremely good eyesight? The mathematical precision required to create these lines is staggering when you actually think about it. To draw a massive spider or hummingbird that looks proportionally correct from altitude, you need to scale up your design accurately. You can't just eyeball it and hope for the best. The Nazca people must have had some kind of grid system or scaling method that allowed them to transfer smaller designs into these enormous geoglyphs while maintaining proper proportions. Modern experiments have shown that it's possible to create these kinds of figures using stakes, ropes, and careful planning, but it requires serious mathematical knowledge and meticulous execution. One mistake when you're creating a 300-foot condor and you end up with something that looks more like a deformed pigeon. What's particularly interesting is that the Nazca people weren't just randomly drawing whatever came to mind. The animals depicted are specific creatures that held significance in Nazca mythology and religion. Creatures associated with water, fertility, and the sky. The hummingbird was connected to fertility and rainfall. The spider was associated with rain prediction. The monkey might have been linked to the constellation we now call Ursa Major. These weren't arbitrary choices. They were carefully selected symbols that meant something profound to the people creating them. Though what exactly they meant, and how exactly the Nazca people used these massive desert drawings, remains frustratingly unclear. The preservation of the Nazca lines is honestly miraculous. The region receives less than an inch of rain per year, and there's minimal wind erosion, which means these shallow excavations haven't been filled in or worn away over 2 millennia. If these lines had been created literally anywhere else on Earth, they'd be long gone by now. But the Nazca Desert Plateau is one of the driest places on the planet, and the climate has remained stable enough that footprints from the original creators are still visible in some areas. You can literally see where someone walked 2,000 years ago to clear away rocks and create these designs. It's simultaneously amazing and slightly creepy, like finding ancient fingerprints frozen in time. Modern threats to the Nazca lines are significantly more concerning than ancient erosion. In 2014, Greenpeace activists walked onto the lines to set up a protest banner near the famous hummingbird design, leaving permanent footprints in a protected archaeological site. UNESCO, which designated the Nazca lines as a World Heritage Site, was understandably furious. In 2018, a truck driver decided the best route across the desert was straight through 3 of the ancient designs, leaving deep tyre tracks that damaged the geoglyphs. Because apparently some people see mysterious ancient artwork and think, yeah, that looks like a good shortcut. The Peruvian government has since increased security and restricted access, but the fact that these lines survived 2,000 years of natural forces only to be threatened by modern carelessness is pretty depressing. The discovery of the Nazca lines in their full glory is a fairly recent story. While locals had always known about the cleared paths in the desert, the true extent and nature of the lines only became apparent when commercial flights started passing over the region in the 1920s and 1930s. Pilots looking down saw these enormous patterns and geometric shapes and basically thought they were hallucinating. Early reports described seeing landing strips and ancient highways, because when you see perfectly straight lines stretching for miles across the desert, your brain doesn't immediately jump to massive religious artwork. It took systematic aerial photography and years of ground surveys to catalogue and understand the full scope of what the Nazca people had created. One of the most persistent fringe theories about the Nazca lines involves ancient aliens, because of course it does. The logic goes something like, the lines can only be seen from the air. Humans in 500 BC couldn't fly, therefore they must have been created as landing strips or messages for extraterrestrial visitors. This theory conveniently ignores the fact that the lines are way too irregular to serve as landing strips, that ancient people were perfectly capable of planning large-scale projects without alien assistance, and that creating artwork for deities you believe live in the sky is a perfectly reasonable religious practice. But sure, let's credit aliens instead of giving the Nazca people credit for their own impressive achievements. That seems fair. What we do know for certain is that the Nazca culture was sophisticated, organised, and clearly capable of long-term planning and execution on a massive scale. They built underground aqueducts called puquios that are still in use today, created elaborate pottery with complex designs, and developed agricultural techniques suited to their harsh desert environment. The Nazca lines represent just one aspect of their cultural achievement, albeit the most visually spectacular one. These people weren't primitive or backwards. They were skilled engineers, artists, and astronomers who created something that has endured for over 2,000 years and continues to puzzle researchers today. If you thought ancient people being mysterious was exhausting, buckle up for the story of an emperor who was so paranoid about the afterlife that he built an entire underground kingdom complete with rivers of mercury and thousands of clay soldiers. I'm talking about Qin Shi Huang, the first emperor of unified China, whose tomb complex is simultaneously one of the most famous and least explored archaeological sites in the world. And before you ask why archaeologists haven't just opened it up to see what's inside, well, that's where things get complicated, and by complicated I mean potentially deadly. Qin Shi Huang was the kind of ruler who didn't do anything halfway. This was a man who unified warring Chinese states into a single empire, standardized currency, weights, and measurements, built massive sections of what would become the Great Wall, and then decided his afterlife accommodations needed to be equally impressive. So naturally he commissioned a tomb complex so elaborate that it took 700,000 workers nearly 40 years to construct. For context, that's roughly the population of Washington, D.C., all labouring for 4 decades to build one really fancy grave. Talk about a massive public works project. The existence of the tomb has been known for over 2,000 years, thanks to ancient Chinese historical records, particularly the writings of Sima Qian, a historian who wrote about it roughly a century after Qin Shi Huang's death. Sima described the tomb's interior in terms that sound absolutely bonkers. A bronze ceiling studded with pearls to represent stars in the night sky, models of palaces and government buildings, and, here's where it gets really wild, rivers of mercury. flowing through channels carved to represent the major waterways of China. Oh, and automatic crossbows set up as booby traps to shoot anyone who tried to break in. Because apparently the emperor trusted his defences about as much as you'd trust a security system designed by someone who's seen too many action movies. For the longest time, historians figured Sima Qian was exaggerating for dramatic effect, because come on, rivers of mercury. That's the kind of thing that sounds impressive but seems logistically impossible. Except modern soil testing around the tomb mound has revealed something interesting. There are indeed abnormally high levels of mercury in the soil, like way higher than should naturally occur, which suggests that either Sima Qian was telling the truth about the mercury rivers, or there's some other really weird explanation for why the soil around an ancient emperor's tomb is contaminated with toxic heavy metals. Personally, I'm leaning toward the ancient records were actually accurate and there really are rivers of mercury down there, because that's somehow less disturbing than the alternatives. The famous Terracotta Army was discovered completely by accident in 1974 when some farmers were digging a well and hit what they initially thought was a broken pottery statue. Imagine their surprise when that one statue turned out to be part of an army of thousands. The Terracotta Army consists of approximately 8,000 soldiers, 130 chariots, 520 horses, and 150 cavalry horses, all arranged in battle formation in massive underground pits. Each soldier is life-sized, individually crafted, and features unique facial features, hairstyles, and expressions. No two are exactly alike, which means someone spent years sculpting thousands of individual clay soldiers with distinct personalities. The level of dedication is honestly impressive and slightly concerning. But here's the thing, the Terracotta Army isn't the main event. Those thousands of warriors are just the guards for the actual tomb, which sits under a massive earthen mound about a mile away and remains completely unopened. The mound is about 250 feet tall and covers roughly 38 square miles when you include all the associated structures and pits. That's not a tomb, that's a small city buried under a hill. And inside that mound is supposedly the burial chamber of Qin Shi Huang himself, surrounded by all the treasures, artifacts, and potentially lethal surprises he wanted to take with him to the afterlife. So why haven't archaeologists opened it? Several very good reasons, actually. First, there's the whole rivers of mercury situation. If there really are channels of liquid mercury sealed inside the tomb, opening it could release toxic mercury vapor that would be extremely dangerous to anyone nearby. Mercury poisoning is no joke. It causes neurological damage, organ failure, and all sorts of unpleasant side effects that tend to dampen archaeological enthusiasm. The Chinese government and archaeological community have decided that maybe we should be absolutely certain about safety protocols before cracking open what might be a 2,000-year-old toxic waste containment vessel. Second, there's the concern about preservation. The terracotta warriors were originally painted in bright colours, blues, reds, greens, purples, but when they were first excavated, the paint began flaking off within minutes of exposure to air. Despite the best efforts of conservators, most of the original paint is now gone, leaving behind the greyish clay we see today. That experience taught archaeologists a harsh lesson about the dangers of excavating ancient sealed environments before having the technology to properly preserve what's inside. If the tomb's interior contains silk, wood, paper, or other organic materials that have survived for 2 millennia in a sealed environment, exposing them to air could destroy them before anyone has a chance to study or preserve them. Third, there are the booby traps. Now you might think that traps set 2,000 years ago couldn't possibly still be functional. But here's the thing. Crossbows are mechanical devices that don't require electricity or any kind of power source to remain set. If you've got a loaded crossbow with a trigger mechanism, it can theoretically stay armed for centuries if properly maintained in a dry, sealed environment. Are there really working crossbows down there waiting to shoot the first person who opens the wrong door? Maybe not, but do you really want to volunteer to find out? Archaeologists already have enough occupational hazards without adding shot by ancient anti-theft system to the list. The Chinese government's official position is that the tomb will remain sealed until preservation technology advances to the point where they can guarantee the safety of both the excavation team and the artifacts inside. Which is honestly the responsible choice, even if it's frustrating for everyone who wants to know what's actually in there. There's no point in opening the tomb only to watch priceless artifacts disintegrate or unleash mercury vapor on your archaeological team. Better to wait and do it right than to rush in and destroy irreplaceable pieces of history because you were impatient. Meanwhile, archaeologists continue to excavate the surrounding areas and study the parts of the complex that are accessible. And they keep finding more stuff. Additional pits containing bronze chariots, clay musicians, acrobats, and administrative officials. Burial pits for actual horses and other animals. Evidence of workshops where the terracotta army was manufactured. Each new discovery reveals more about the scale and ambition of Qin Shi Huang's afterlife preparations. This guy really wanted to make sure he had everything he needed in the next world, including an army, entertainment, transportation, and administrative staff. Because apparently being emperor is a job that extends beyond death. The craftsmanship on the terracotta warriors is genuinely remarkable. These aren't crude clay dolls. They're sophisticated sculptures with detailed armor, weapons, and realistic features. The soldiers were originally armed with real bronze weapons, many of which were still sharp when excavated despite being buried for over 2,000 years. The weapons show evidence of advanced metallurgy, including chromium plating that prevented corrosion. Yes, chromium plating, a technique that supposedly wasn't invented until the 20th century in the West. Either the ancient Chinese were way ahead in metallurgical technology, or those weapons got very lucky with their burial conditions. Either way, it's another example of ancient technology being more sophisticated than we generally give it credit for. The organization required to build this complex is staggering. 700,000 workers laboring for 4 decades, all coordinated to create an underground necropolis. Someone had to plan it, design it, manage the workforce, procure materials, and ensure quality control on thousands of individual clay sculptures. The logistics alone would be a nightmare even with modern project management tools. Now imagine doing it with messengers on horseback and wooden tallying sticks. The level of bureaucratic organization required is almost as impressive as the artistic achievement. Historical records mention that all the workers who knew the location of the tomb's entrances and the layout of its traps were killed after completion to preserve its secrets, which is both horrifying and, from a security standpoint, extremely effective. Can't have security breaches if everyone who knows the security system is dead. Qin Shi Huang was clearly not taking any chances with tomb robbers. Whether this mass execution actually happened is debated by historians, but given the emperor's reputation for ruthlessness, it wouldn't be entirely out of character. Modern technology has allowed researchers to study the tomb without opening it. Ground-penetrating radar, electromagnetic surveys, and other non-invasive techniques have confirmed that there are indeed large void spaces under the mound, consistent with the chamber structure described in ancient records. The surveys have also detected what might be walls, corridors, and various structures, though interpreting the data is challenging. It's like trying to map a building by standing outside and using sonar. You can get a general sense of what's there, but you can't see the details until you actually go inside. The mercury question continues to fascinate researchers. If there really are flowing rivers of mercury down there, how were they constructed? Mercury is liquid at room temperature, so you'd need channels carved precisely to allow it to flow, but also sealed well enough that it doesn't leak out or evaporate over 2 millennia. The engineering involved would be remarkably sophisticated. And why mercury? Was it purely symbolic, representing the sacred rivers of China in eternal flowing form? Was it believed to have preservative properties? Did Qin Shi Huang think it would grant him immortality in the afterlife? Ironically, mercury is highly toxic, so if the emperor's goal was eternal life, he might have picked the wrong material. There's also the darker possibility that the mercury was intentional protection against tomb robbers. Mercury vapor is poisonous. It causes respiratory problems, neurological damage, and death if you're exposed to enough of it. Anyone who managed to get past the crossbow traps and make it into the burial chamber might find themselves breathing toxic fumes, which would be a pretty effective deterrent against theft. Whether this was intentional or just a fortunate side effect of the emperor's aesthetic choices, we won't know until someone actually gets in there and survives long enough to tell us about it. The tomb of Qin Shi Huang represents the ultimate archaeological paradox. We know it exists, we know roughly where it is, we have historical descriptions of what's supposedly inside, and we even have technology that could allow us to open it. But the risks, to both the archaeologists and the artifacts, are significant enough that the responsible choice is to leave it sealed. It's frustrating, tantalizing, and absolutely the right call. Some mysteries are worth waiting for, especially when the alternative is potentially destroying irreplaceable pieces of human history or poisoning your research team with ancient mercury booby traps. So for now, the tomb remains China's forbidden necropolis, sitting under its grass-covered mound, guarding secrets that have stayed hidden for over 2,000 years. The terracotta army stands eternal watch over their emperor, frozen in formation, waiting for orders that will never come. And somewhere beneath that hill, surrounded by flowing mercury and mechanical crossbows, Qin Shi Huang rests in his bronze palace under a sky of pearls, probably quite satisfied that his afterlife arrangements are still impressing and baffling people. 2 millennia later. Mission accomplished, Emperor. Mission very much accomplished. Right, so we've covered ancient computers, prehistoric temples that shouldn't exist, impossible stone moving, desert art for sky watchers, and underground palaces guarded by clay armies. Now let's talk about something that might be the most audacious construction project in human history. A temple that someone decided to carve out of a mountain. Not build on top of a mountain, not construct using stones quarried from a mountain, actually carve the entire temple out of solid rock by removing everything that isn't temple. It's like the world's largest sculpture project combined with the world's most ambitious demolition job, and it's called the Kailasa Temple. Located in Ellora, Maharashtra, India, the Kailasa Temple is the world's largest monolithic structure, which is a fancy archaeological way of saying carved from one gigantic piece of rock. This isn't a building made of individual stones stacked. Together, it's literally excavated from the bedrock of a cliff face. The builders started at the top of the rock formation and worked their way down, carving out the temple's towers, courtyards, pillars, statues, and intricate decorative elements by removing approximately 400,000 tons of volcanic basalt. 400,000 tons. That's roughly the weight of 2 aircraft carriers, for those keeping score at home. All of this was accomplished using hammers and chisels, because power tools were still about 1,200 years away from being invented. The construction supposedly took place during the reign of the Rashtrakuta King Krishna I in the 8th century, and according to historical estimates, the entire project was completed in about 18 years. 18 years to remove 400,000 tons of extremely hard volcanic rock, carve it into an elaborate 3-story temple complex with detailed sculptures covering every available surface, and do it all while working from top to bottom so you can't really tell if you made a mistake until it's way too late to fix it. No pressure or anything. Modern engineers have calculated that to remove that much basalt in 18 years, workers would need to excavate roughly 60 tons of rock every single day, without breaks, including weekends and holidays. Merry Christmas, back to carving the temple. Here's what makes this approach absolutely bonkers from an engineering perspective. When you carve from the top down, you can't make significant mistakes. If you're building a temple the normal way, stacking stones on top of each other, and you mess something up, you can remove that stone and try again. No big deal. But when you're carving downward, removing material that can never be put back, every chisel strike needs to be intentional and accurate. You can't add material back if you remove too much. There's no undo button. It's like carving a sculpture, except your sculpture is 3 stories tall, covers an area the size of a football field, and one major error means you've just permanently ruined years of work. The stress levels must have been astronomical. The temple itself is dedicated to Lord Shiva and is designed to represent Mount Kailash, Shiva's legendary abode in Hindu mythology. The complex includes a main temple tower that stands about 100 feet tall, a separate tower for Nandi the bull, courtyards, smaller shrines, and a series of elephants carved into the base that appear to be supporting the entire structure. The architectural style is spectacular, with multiple levels, intricate pillars, elaborate brackets, and an overall design that would be impressive if it were constructed from individual stones. The fact that it's all carved from one continuous piece of rock is almost incomprehensible, but it's the decorative details that really make your jaw drop. The walls of the Kailasa temple are covered with incredibly intricate reliefs, depicting scenes from Hindu epics like the Ramayana and Mahabharata, images of various deities, demons, celestial beings, and mythological creatures. The level of detail is extraordinary. Individual fingers on hands, expressions on faces, folds in clothing, jewellery, weapons, all carved with precision that rivals the work of master sculptors. There are panels showing massive battle scenes with dozens of figures interacting, dance performances, religious ceremonies, and cosmic events. The sculptors weren't just removing rock to create a building, they were creating an entire visual encyclopedia of Hindu mythology and artistic expression. According to some sources, the temple contains over 30 million Sanskrit characters carved into its surfaces. 30 million. Even if that number is exaggerated, and honestly, who's counting at that point, we're still talking about an absolutely staggering amount of detailed carving. Someone, or more accurately many someones, spent years of their lives carefully chiseling letters into basalt rock, one character at a time. The patience required is beyond comprehension. Modern stoneworkers using power tools would look at this project and politely decline, possibly while laughing at the absurdity of the timeline and scope. The question that keeps researchers up at night is, how did they actually do this? The official answer is hammers and chisels, which is technically correct but feels wildly insufficient as an explanation. Basalt is one of the hardest types of rock you can carve. It's volcanic, extremely dense, and resistant to both weathering and carving. Working basalt even with modern diamond-tipped tools is challenging. Working it with iron chisels would be slow, labour-intensive, and require constant sharpening and replacement of tools. The number of chisels that would have been worn out or broken during this project must have been enormous. There was probably a whole industry just supplying replacement tools to the temple carvers. The precision of the carving raises additional questions. The pillars are perfectly vertical, the floors level, the proportions mathematically accurate. How do you achieve that level of precision when you're removing material from above? You can't use a level in the traditional sense because you're not building up, you're carving down. You need to visualize the final structure in 3 dimensions and remove everything that isn't part of that vision, all while maintaining structural integrity so your temple doesn't collapse halfway through construction. The spatial reasoning and planning required is extraordinary. These weren't people randomly hacking away at rock, hoping something temple-shaped would emerge. This was carefully planned, precisely executed, and remarkably successful architectural engineering. Modern attempts to understand the construction methods have involved everything from computer modelling to experimental archaeology. Researchers have tried recreating small sections of basalt carving using period-appropriate tools, and the results have been humbling. It's possible to carve basalt with iron chisels, but it's incredibly slow work. We're talking about removing perhaps a few cubic inches of rock per hour, per worker, depending on the hardness of the specific basalt being carved. Scale that up to 400,000 tons, and even with thousands of workers labouring constantly, 18 years starts to seem impossibly short. Either the historical timeline is wrong, or the workers were extraordinarily efficient, or there were techniques being used that we don't fully understand yet. Some researchers have proposed that the carvers used a technique involving heating the rock with fire and then rapidly cooling it with water, causing the surface to fracture and making it easier to remove. This thermal shock method could potentially speed up the excavation process, though controlling it precisely enough to create detailed sculptures seems problematic. You'd risk cracking the rock in unintended ways or creating structural weaknesses. Others have suggested that the hardness of basalt might have been advantageous in some ways. Once carved, it would hold detail extremely well and resist erosion, meaning the sculptors could work with finer detail than would be possible in softer stone. Still doesn't explain how they carved it so quickly, though. The structural engineering is equally impressive. When you carve a building out of solid rock, you have to account for all the same structural concerns as conventional construction: load-bearing elements, weight distribution, stability, except you're doing it in reverse. Instead of adding supporting elements, you're removing everything except the support structures. The pillars holding up the roof of the main temple had to be left intact, while everything around them was excavated away. One mistake in calculating which sections of rock needed to remain for structural support, and the whole thing could collapse. The fact that the temple is still standing after 1,300 years suggests they got the calculations exactly right, which is remarkable given that structural engineering as a formal discipline wouldn't exist for another 1,000 years. There are also practical questions about how the work was organised. Did carvers work in teams, each responsible for specific sections? How did they coordinate to ensure that the different sections lined up properly when they met? How did they get workers up and down the carving site? Scaffolding would have been necessary for the detailed work on upper levels, but that scaffolding would need to be constantly adjusted as the excavation progressed downward. The logistics of managing potentially thousands of workers, all carving simultaneously at different levels of the same structure, without modern communication tools or project management software, is mind-boggling. There must have been extensive planning documents, scale models, or some system for ensuring everyone was working toward the same vision. Unfortunately, if such documents existed, they haven't survived. The Kailasa Temple isn't alone at Ellora. It's part of a complex of 34 cave temples and monasteries carved into the same rock face, representing Buddhist, Hindu, and Jain traditions. The other structures are impressive in their own right, but Kailasa is in a league of its own in terms of scale and ambition. It's as if the other temples were warm-up exercises, and then someone decided to show off by carving something that would make all the previous efforts look like practice sketches. The fact that multiple religious communities were able to create such elaborate rock-cut architecture in the same location suggests there was a rich tradition of stone carving in the region. But even within that tradition, Kailasa stands out as exceptional. What's particularly fascinating is that this wasn't the only rock-cut temple in India. There are dozens of similar structures across the country, though none quite as massive as Kailasa. The Ajanta Caves, the Elephanta Caves, the cave temples at Badami. India has a whole architectural tradition of carving religious structures out of solid rock, rather than building them from quarried stones. This suggests that the techniques and skills required weren't unknown or lost technology. They were part of an established construction tradition. But even within that tradition, Kailasa represents the absolute pinnacle of achievement, the masterpiece that pushed the boundaries of what was technically possible. The temple's survival through centuries of monsoons, earthquakes, and general wear and tear is itself remarkable. Basalt is durable, but it's not indestructible. The fact that the intricate carvings and delicate architectural details have survived relatively intact, aside from some weathering and damage from vandalism in later periods, speaks to both the quality of the original workmanship and the inherent strength of monolithic construction. When your entire temple is carved from one piece of rock, there are no joints to fail, no mortar to deteriorate, no individual stones to shift or collapse. The structural integrity comes from the stone itself, which turns out to be a pretty good foundation for long-term preservation. Visiting the Kailasa temple today is a somewhat surreal experience. It's difficult for the human brain to fully process that what you're looking at isn't a building that was constructed, but rather the negative space left after removing everything that wasn't the building. You're standing in an enormous excavation pit, looking at a multi-story temple that exists because someone decided that removing hundreds of thousands of tons of rock was the best way to honor their deity. The sheer audacity of the concept is breathtaking. It's the architectural equivalent of Michelangelo's quote about sculpting. He didn't carve the statue, he just removed everything that wasn't the statue. Except instead of a statue, it's a 3-story temple complex. Modern conservation efforts focus on protecting the temple from pollution, weathering, and the millions of tourists who visit annually. There's ongoing debate about the best methods for preservation. How do you protect something that's carved into a mountainside without fundamentally altering its character? Some areas have been stabilized with discrete reinforcement, and efforts have been made to control water runoff that could accelerate erosion. But fundamentally, the temple remains as it was created, a testament to what human beings can accomplish with apparently primitive tools, unlimited determination, and a complete disregard for the concept of reasonable project scope. The Kailasa temple forces us to reconsider our assumptions about what ancient civilizations were capable of achieving. We tend to think of impressive architecture in terms of buildings constructed from individual components, the pyramids, the Parthenon, Gothic cathedrals. But here's a structure that required an entirely different approach, one that demanded perhaps even greater precision and planning than conventional construction. There's no margin for error when you're working in subtractive rather than additive architecture. Every piece removed is permanent, every design decision is final. And yet the builders pulled it off, creating something that still impresses and puzzles observers 1,300 years later. Whether they used forgotten techniques, possessed skills that have been lost to time, or simply applied extraordinary determination and craftsmanship using the tools available to them, the result speaks for itself. Sometimes the most remarkable human achievements are the ones that make us question whether we could replicate them, even with all our modern technology and knowledge. The Kailasa Temple is definitely one of those achievements. So we've established that ancient people could carve entire temples out of mountains. But what if I told you there's a massive stone structure sitting underwater off the coast of Japan that might predate all known civilizations? And I don't mean it sank recently. I mean it might have been built when the ocean was 130 feet lower than it is today during the last ice age, which would make it over 10,000 years old. Welcome to the Yonaguni Monument, where the debate isn't just about how it was built, but whether humans built it at all, or if we're just really good at seeing patterns in random rock formations. Spoiler alert, geologists and archaeologists have been screaming at each other about this for nearly 40 years, and they're no closer to agreeing. The story starts in 1985, which is recent enough that the discoverer, a dive tour operator named Kihachiro Arataki, is still alive to tell the tale. Arataki was exploring the waters off Yonaguni Island, the westernmost inhabited island of Japan, looking for interesting dive sites to show tourists. You know, typical stuff. Coral reefs, tropical fish, maybe some interesting rock formations. What he found instead was a massive underwater structure featuring terraces, right angles, flat surfaces, and what appear to be deliberately carved steps. Imagine being a dive tour operator thinking you're going to find some nice coral, and instead you surface with, "Hey guys, I think I found Atlantis." Not exactly the average Tuesday at work. The structure is enormous, roughly 165 feet long and 65 feet wide, sitting at a depth of about 80 feet below the surface. It features multiple levels connected by what look like stairways, flat platforms that are unnaturally level, sharp 90-degree angles, and formations that resemble walls, pillars, and even what some people claim is a carved face or statue. The main formation has 5 distinct layers, each one a perfect terrace stepping down to the next level, which is either a remarkable coincidence of geology or someone's idea of monumental architecture. Depending on which expert you ask, it's either the most significant archaeological find of the century, or just rocks being rocks in ways that happen to look impressive. Marine geologist Masaki Kimura from the University of the Ryukyus has spent decades studying the Yonaguni Monument, and he's firmly in the "this is absolutely man-made" camp. Kimura has documented what he believes are tool marks, quarry marks, and deliberately shaped features including right angles that are apparently too precise to occur naturally. He's found what look like post holes, drainage channels, and even markings that might be primitive writing or decorative elements. According to Kimura, the structure shows clear evidence of human modification, particularly in features like the perfectly flat platforms and the stairway that has 5-inch-high steps at regular intervals. Because apparently nature is really into standardized building codes when it creates random rock formations. On the other side of this academic cage match, we have geologist Robert Schoch from Boston University, who visited the site and basically said, "Nah, that's just how sandstone fractures." Schoch, who's a geologist specializing in rocks and weathering patterns, argues that the Yonaguni Monument is a natural formation created by tectonic activity and erosion. Sandstone has a tendency to fracture along straight lines due to its layered structure, and underwater currents can create flat surfaces and terraces that look artificial. According to Schoch, what we're seeing is confirmation bias. We want it to be an ancient structure, so we interpret natural geological features as man-made architecture. It's like seeing shapes in clouds, except the clouds are underwater and made of rock. Here's where things get interesting from a timeline perspective. If the Yonaguni Monument is artificial, it would have been built when sea levels were significantly lower than they are today. The last time this area was above water was at the end of the last ice age, roughly 10,000 to 12,000 years ago. That's several thousand years before the construction of the Egyptian pyramids, before Göbekli Tepe, before pretty much any known monumental architecture anywhere on Earth. We'd be talking about a prehistoric civilization sophisticated enough to quarry stone, create precise angles and measurements, and construct multi-level platforms, all before humans supposedly figured out agriculture. No pressure on rewriting the entire timeline of human development or anything. The geological debate centers on some pretty specific details. Natural sandstone formations can absolutely create straight edges and flat surfaces through a process called joint formation, where rock fractures along natural weak points. Underwater erosion by currents can smooth surfaces and create features that look deliberately shaped. Tectonic activity in the region, and Yonaguni is in a very tectonically active area, can shift and arrange rock formations in ways that seem impossibly organized. But here's the problem. While each individual feature might be explainable by natural processes, having all of them occur together in one location is statistically less likely. It's possible, just weird. Kimura points to specific features that he argues couldn't have formed naturally. There's a formation that looks like a carved turtle, complete with what appear to be eyes and a mouth. There are what seem to be drainage channels that direct water flow in specific directions. There are holes that appear to be deliberately drilled into the rock at regular intervals, as if they once held wooden posts or supports. Most compellingly, there are areas where the rock appears to have been cut and removed, with the removed blocks found nearby in positions that suggest they were quarried and relocated. Of course, skeptics argue that all of these features can be explained by selective fracturing, random erosion patterns, and a whole lot of wishful thinking, which is fair but also considerably less exciting. One of the most contentious aspects of the debate is the so-called main terrace, or platform, which is a flat expanse of rock measuring roughly 165 feet by 50 feet that's level to within a few degrees. Proponents of the artificial origin theory point out that getting a surface this flat and level through random natural processes seems highly unlikely. Natural rock formations tend to have irregularities, slopes, and variations that you don't see here. Skeptics counter that selective erosion can absolutely create flat surfaces, and that level to within a few degrees isn't actually that precise. It just looks impressive when you're standing on it. The argument basically boils down to that seems unlikely, versus unlikely things happen all the time, which is a philosophically interesting debate but not super helpful for determining what actually happened. There's also the question of the road or loop road, a feature that runs around the structure and connects various levels. It's between 3 and 6 feet wide, relatively flat, and follows the contours of the formation in what looks like a deliberately planned path. If you were designing an ancient stone structure, you'd probably want pathways connecting different levels. If you're geology creating random formations, you might occasionally produce something that looks like a pathway, but is actually just a gap where rock fractured and eroded. The problem is that without other clear evidence, like tool marks that are definitively man-made or artifacts found in context, it's really hard to say for certain which explanation is correct. What would prove the Yonaguni monument is artificial? Finding tools, pottery, building materials, or other artifacts in direct association with the structure would be pretty convincing. Discovering inscriptions or decorative elements that are clearly man-made would seal the deal. Identifying quarry marks or tool signatures that match known ancient construction techniques would help. But here's the catch. If this structure really is 10,000 years old and has been underwater for most of that time, any organic materials like wood or rope would have long since decomposed. Pottery and tools could have been scattered by currents or buried in sediment. The ocean is not great for archaeological preservation, especially over thousands of years. Some researchers have suggested that the truth might be somewhere in the middle, that the Yonaguni monument is a natural formation that was modified or enhanced by humans. Maybe ancient people found these interesting rock terraces and added some steps, created some platforms, or carved some features to make the natural formation more useful for their purposes. This would explain why some features look natural while others appear suspiciously artificial. It's the archaeological equivalent of finding a cave and adding doors and windows. You're working with what nature provided but modifying it to suit your needs. This compromise theory makes nobody happy, which is often a sign that it might actually be close to the truth. The cultural context adds another layer to the mystery. Yonaguni Island has ancient legends about a lost land called Mu, or Lemuria, that supposedly sank beneath the waves thousands of years ago. These legends exist throughout the Pacific and could be cultural memories of actual land loss due to rising sea levels at the end of the Ice Age. If people were living in this region when sea levels were lower, they would have witnessed their coastal settlements gradually being swallowed by the ocean over generations. That's the kind of event that gets remembered in oral traditions and legends. Whether those legends have any connection to the Yonaguni monument is pure speculation, but it's interesting speculation. Modern technology has allowed for increasingly detailed study of the site. 3D scanning, detailed photogrammetry, and advanced diving equipment have enabled researchers to map the structure with unprecedented accuracy. Multiple academic teams have studied the monument, produced detailed reports, and arrived at completely contradictory conclusions, which is always fun for science. Some teams find clear evidence of human modification. Others see nothing but natural geological processes. It's like a giant underwater Rorschach test, where geologists and archaeologists project their professional biases onto ambiguous rock formations. What makes the Yonaguni Monument particularly challenging to study is that you can't easily excavate it. On land, archaeologists would dig test trenches, examine soil layers, and carefully document everything in context. Underwater archaeology is significantly more complicated. You're working in an environment that's hostile to humans, with limited bottom time, strong currents, and visibility that varies from decent to can't see your hand in front of your face. Any excavation has to be done carefully to avoid disturbing the site or losing artifacts to currents. And unlike land archaeology, where you can take your time, underwater work is constrained by air supply, decompression limits, and the physical demands of diving. It's like trying to do delicate scientific work while holding your breath and fighting against constant water movement. The debate over Yonaguni has become somewhat heated over the years, with proponents and skeptics occasionally getting personal in their criticisms. Kimura has accused skeptics of dismissing evidence without properly examining it. Schoch has suggested that proponents are seeing what they want to see rather than what's actually there. Other researchers have weighed in on both sides, and the academic literature contains papers arguing passionately for natural origins, artificial construction, and various hybrid theories. It's become less about the evidence and more about defending positions, which is unfortunate but pretty typical of controversial archaeological debates. What's fascinating is that regardless of whether the Yonaguni Monument is natural or artificial, it raises important questions about our understanding of the past. If it's natural, it's still a remarkable geological formation that demonstrates how nature can create structures that look almost impossibly organized and planned. If it's artificial, it pushes back the timeline of complex human construction by thousands of years and suggests there were sophisticated cultures that we know almost nothing about. Either way, it challenges our assumptions and forces us to think more carefully about how we interpret evidence and what we think we know about ancient history. The site has become a popular dive destination, which has its pros and cons. On one hand, the increased attention has led to more study and documentation. On the other hand, having thousands of divers visiting annually increases the risk of damage to features that might be evidence of human construction, or might just be interesting rocks. The Japanese government has designated the area around Yonaguni as a protected site, but enforcement is challenging when the site is underwater and accessible to anyone with scuba certification and a boat. So what's the verdict? Honestly, we don't have one. The Yonaguni Monument remains one of the most contentious underwater sites in the world, with passionate advocates on both sides of the natural versus artificial debate. More research might eventually settle the question, or we might be arguing about this for another 40 years. The structure isn't going anywhere. It's been sitting underwater for at least 10,000 years, so it can probably wait a bit longer for us to figure out what it actually is. In the meantime, it serves as a fascinating reminder that there's still plenty about our past that we don't understand, and that sometimes the biggest mysteries are the ones where we can't even agree on what the mystery actually is. Is it an ancient monument? Is it rocks being rocks? Is the real mystery the friends we made along the way? Who knows? But it's definitely fun to dive on, which is probably enough for Kihachiro Arataki, who just wanted to find cool stuff to show tourists and ended up triggering one of the longest-running debates in underwater archaeology. Mission accomplished, I guess. Alright, we've covered underwater maybe pyramids that nobody can agree on, so let's switch gears to something completely different. A book that's been sitting in libraries for 600 years that literally nobody can read. Not hard to read or requires specialized knowledge to understand, but genuinely, completely, utterly indecipherable. I'm talking about the Voynich manuscript, a medieval document written in an alphabet that doesn't match any known language, filled with illustrations of plants that don't exist, astronomical diagrams that make no sense, and drawings of naked women. Bathing in green liquid for reasons that remain, unsurprisingly, completely mysterious. It's like someone from the 15th century decided to write the world's most elaborate prank and succeeded so well that we're still falling for it 6 centuries later. The manuscript is named after Wilfrid Voynich, a Polish book dealer who acquired it in 1912 from the Jesuit college at the Villa Mondragone in Italy. Voynich, who was probably expecting to find some nice medieval texts he could sell to collectors, instead discovered what might be the most frustrating document in human history. The book is about 240 pages long, written on vellum, that's animal skin, the fancy expensive writing material of the medieval period, and filled with text in an unknown script accompanied by bizarre illustrations. Voynich immediately recognised that he'd found something special, by which I mean something that would drive scholars absolutely insane for the next century and beyond. The writing system used in the manuscript is unique. It features about 20 to 30 distinct characters, depending on how you count variations, arranged into what looks like sentences and paragraphs. The text flows naturally, with clear word breaks, and shows statistical properties that suggest it's actually a language rather than random nonsense. There are repeating patterns, word frequencies that match natural language distributions, and structural elements that indicate the author knew what they were doing. But here's the catch. Nobody has any idea what language it is. It doesn't match Latin, which was the scholarly language of medieval Europe. It doesn't match any known European language, Asian language, or Middle Eastern language. Linguistic analysis has been run on this thing more times than anyone can count, and the results always come back the same. It looks like language, it acts like language, but we have absolutely no clue what language it actually is. The illustrations are where things get really weird. The manuscript is divided into several sections based on the types of drawings, and each section is more puzzling than the last. There's a botanical section featuring detailed drawings of plants. Sounds normal, right? Except none of these plants exist. They're not European plants, not Asian plants, not plants from anywhere on Earth. Some of them look vaguely familiar. You might see something that resembles a sunflower or a vine. But then there are extra parts, weird root systems or strange flowers that don't match any known species. Either the artist was documenting plants that have since gone extinct, or they were really into fantasy botany, or they were drawing plants from memory while suffering from severe hallucinations, all equally plausible at this point. Then there's the astronomical section, which features circular diagrams that might be related to the zodiac or celestial observations. These diagrams have labels in the mysterious script, show what might be stars or planets, and include human figures that could represent constellations. Some researchers think this section might be an astrological calendar or astronomical reference guide. Others think it's just decorative nonsense. The diagrams are elaborate and clearly took significant time to create, which suggests they meant something to whoever made them. What that something is remains anyone's guess. It's like finding a textbook from another dimension, where the laws of botany and astronomy are slightly different but still just familiar enough to be confusing. But the section that really gets people talking is what's called the balneological section, which is a fancy academic way of saying the part with all the naked ladies in bathtubs. This section features dozens of small illustrations of nude women, often shown bathing in or emerging from elaborate systems of tubes, pools, and containers filled with what appears to be green or blue liquid. Some of the women are connected to pipes or channels, some are sitting in individual tubs, and some are standing in pools together. The whole thing looks like a bizarre medieval spa diagram or possibly the world's strangest plumbing manual. Theories about what this section represents range from alchemical processes to medicinal bathing practices to an elaborate metaphor for something. Nobody really knows, and at this point most researchers have just accepted that naked ladies in green liquid is a thing in this manuscript and moved on. The manuscript has attracted attention from some of the brightest minds in cryptography, linguistics, and medieval studies. During World War II, top codebreakers who were successfully cracking complex enemy ciphers took a crack at the Voynich manuscript during their downtime. They failed. In the 1970s, the NSA, yes, the National Security Agency, the people whose literal job is breaking codes, had their experts analyze it. They also failed. Modern computer analysis, statistical methods, artificial intelligence, machine learning algorithms that can translate ancient languages and decode complex ciphers all have been applied to the Voynich manuscript with minimal success. It's like the manuscript is specifically designed to resist every method we throw at it, which is either incredibly clever or the ultimate proof that there's nothing there to decode in the first place. This has led to three main theories about what the manuscript actually is. Theory 1, it's a genuine document in an unknown or constructed language, possibly encoding real knowledge about medicine, alchemy, or some other medieval science. This is the optimistic theory that assumes the manuscript has actual content and we just haven't figured out the key yet. Theory 2, it's an elaborate hoax, created by someone who wanted to make money selling a mysterious manuscript to collectors, or wanted to prank future generations of scholars. This is the cynical theory that suggests we've been wasting our time on medieval trolling. Theory 3, and my personal favourite, It's a constructed language or cipher that follows real linguistic rules but doesn't actually mean anything. Essentially glossolalia, speaking in tongues, but written down in an invented script. The medieval equivalent of word salad that looks meaningful but is fundamentally empty. The hoax theory gained significant traction when researchers discovered that the manuscript could plausibly have been created by Edward Kelly, a 16th century con artist and alchemist who worked with John Dee, the famous English mathematician and occultist. Kelly had a reputation for creating fake magical texts and selling them to wealthy collectors, and he would have had the skills and motivation to create something like the Voynich manuscript. The problem with this theory is that carbon dating of the vellum places its creation in the early 15th century, which is before Kelly was born. Unless Kelly had access to time travel, which given that he claimed to talk to angels, he might have considered possible, he couldn't have made it. Though he could have written on older vellum, which people sometimes did, so the debate continues. Some researchers have claimed to have decoded parts of the manuscript over the years, and each announcement generates huge media attention before inevitably falling apart under scrutiny. Someone will announce they've determined it's written in abbreviated Latin, or medieval Hebrew, or an ancient Turkish dialect or whatever. They'll provide a translation of a few pages that seems plausible. Then other scholars examine their methods, find flaws in the logic, and the whole thing collapses. We've been through this cycle dozens of times. It's gotten to the point where most serious academics are deeply skeptical of any new breakthrough in Voynich studies. The manuscript has become the academic equivalent of The Boy Who Cried Wolf, except the boy is a medieval book, and the wolf is meaningful content. What makes the Voynich manuscript particularly frustrating is that everything about it suggests it should be decipherable. The text shows consistent patterns. The illustrations are detailed and specific. The whole thing is carefully organized into sections. This isn't random scribbling. It's a carefully constructed document created by someone who spent significant time and effort on it. Vellum was expensive, ink was expensive, and the labour involved in creating a 240-page illustrated manuscript was enormous. Nobody would go through all that trouble just to create meaningless gibberish, right? Except maybe they would if they were trying to sell it as a valuable mystical text. Or maybe they genuinely believed they were recording real information in a divinely inspired language. Medieval people did some weird stuff in the name of religion and magic. The manuscript's provenance, its ownership history, is itself a mystery for most of its existence. We know it was in the possession of Holy Roman Emperor Rudolph II in the early 17th century, because there are records of him paying 600 ducats for it. That's roughly equivalent to spending tens of thousands of dollars on a book today, which tells us that even in the 1600s, people thought this manuscript was valuable and important. It then passed through various hands before ending up at the Jesuit college where Voynich found it. But where it came from originally, who created it, and why, all completely unknown. It's like the manuscript appeared out of nowhere with no past, just showing up in the historical record, already frustrating everyone who encountered it. Modern technology has at least helped us learn some things about the physical manuscript, even if we can't read it. Multispectral imaging has revealed text that was previously invisible, showing that the author made corrections and edits as they worked. Chemical analysis of the inks and pigments has confirmed they're consistent with medieval materials. The binding, page layout, and physical construction all match what you'd expect from a 15th century European manuscript. So whatever this thing is, it's genuinely old, and was created using period-appropriate materials and techniques. That rules out modern forgery, but doesn't get us any closer to understanding what it says or means. The Voynich manuscript currently resides at Yale University's Beinecke Rare Book and Manuscript Library, where it's been since 1969. It's one of their most popular items, with researchers regularly requesting access to study it, and tourists wanting to see the famous unreadable book. Yale has digitized the entire manuscript and made it available online, which means anyone with an internet connection can now spend hours staring at incomprehensible text and weird plant drawings. You can join the proud tradition of people throughout history who have looked at this manuscript and thought, "What the hell am I looking at?" Democracy in action, truly. Speaking of mysteries that make you question everything you think you know about ancient people, let's talk about Easter Island, also known as Rapa Nui, which features nearly 900 massive stone statues scattered across a remote Pacific island. These aren't your typical stone sculptures. We're talking about multi-ton humanoid figures with elongated heads, massive bodies, and an expression that can best be described as stoic disapproval. They're called moai, and they represent one of the most impressive achievements in Polynesian culture and one of the most persistent mysteries in archaeology. Because here's the thing, we know who made them and roughly when, but the how and why are still subjects of intense debate. Particularly the how, because some of these statues weigh 82 tons and were somehow transported miles across the island without wheels, metal tools, or draft animals. Easter Island is one of the most isolated inhabited places on Earth. It's a tiny speck of volcanic rock in the southeastern Pacific Ocean, roughly 2,000 miles from the nearest continental shore. The island is only about 63 square miles, which is smaller than Washington, D.C., and it sits basically in the middle of nowhere. The fact that Polynesian navigators found this place at all is impressive. They sailed across vast stretches of open ocean in canoes, using star navigation and ocean current knowledge that most modern sailors couldn't replicate. And once they found this remote island, they decided that what it really needed was hundreds of giant stone statues. Because priorities. The moai were carved from volcanic tuff, a relatively soft stone that comes from the Rano Raraku quarry on the island. The Rapa Nui people worked this quarry extensively, and you can still see evidence of their work today. There are nearly 400 moai in various stages of completion still at the quarry, some fully carved but not yet separated from the bedrock, some partially finished, some abandoned mid-carving. It's like walking through a frozen moment in time, seeing exactly what the sculptors were working on when everything suddenly stopped. Which is simultaneously fascinating and kind of eerie, because something obviously went very wrong for an entire civilization to abandon their primary cultural project midway through. The average moai stands about 13 feet tall and weighs around 14 tons, which is already ridiculous. But some of them are significantly larger. The biggest moai that was actually completed and moved is called Paro, standing about 33 feet tall and weighing an estimated 82 tons. That's heavier than a fully loaded semi-truck. And it's not sitting at the quarry where it was carved. It was transported several miles to a coastal location and erected on a ceremonial platform called an ahu. How did the Rapa Nui people move something that heavy without any of the technology we'd consider essential for the job? That's the central mystery, and it's driven researchers to some increasingly creative experiments over the years. Local legends offer one explanation. The moai walked to their locations under their own power. According to Rapa Nui oral traditions, the statues were animated by mana, spiritual power, and moved themselves to their platforms guided by priests and chiefs. Now, before you dismiss this as pure mythology, here's where it gets interesting. Modern archaeologists have discovered that the moai were designed in a way that actually allows them to be walked, using ropes and coordinated movement. The statues have a distinctive shape, large heads, forward-leaning torsos, and a base that's narrower than the top, that makes them naturally unstable, but also allows them to be rocked back and forth while being pulled forward with ropes. Teams of researchers have successfully moved moai replicas by having groups of people pull alternating ropes on either side while others guide with ropes from the front, causing the statue to waddle forward in a walking motion. This walking technique is both brilliant and terrifying to watch. You've got this multi-ton statue rocking side to side, held upright purely by rope tension and the coordination of dozens of people, slowly progressing down what's essentially a dirt path. One mistake, one rope breaking, one person losing their grip, and you've got 14 tons of carved rock toppling over and possibly crushing someone. The fact that the Rapa Nui people successfully moved hundreds of these statues this way, likely over rough terrain and in various weather conditions, speaks to an incredible level of skill, coordination, and probably a fairly high tolerance for risk. Health and safety regulations were not a concern in pre-contact Polynesia, but the moai weren't complete when they reached their platforms. Most of the statues we see photos of are actually wearing hats, or more accurately top knots made from red scoria, a different type of volcanic stone called pukau. These pukau weigh up to 12 tons each and had to be quarried from a different location, transported to where the moai was erected, and then somehow lifted and placed on top of a statue that might already be 20 or 30 feet tall. The engineering required to crown a moai with its pukau without damaging the statue is genuinely impressive. Current theories involve ramps and lever systems, but again, we're talking about lifting 12 tons of stone to significant height using only ropes, wooden poles, and human labour. The Rapa Nui people apparently looked at extremely difficult tasks and thought, yeah, but what if we made it harder? The statues also originally had eyes. Not carved into the stone, but made from white coral with black obsidian or red scoria pupils inserted into the eye sockets during ceremonies. When the Moai were standing on their platforms with their backs to the ocean, facing inland toward the communities they protected, and their coral eyes were in place, they would have looked genuinely alive, and probably pretty intimidating. Imagine seeing these giant stone figures, 13 feet tall or more, with gleaming white eyes staring down at you from their platforms. The psychological impact must have been enormous. Unfortunately, most of the coral eyes have been lost or destroyed over the centuries, though a few have been found and are displayed in museums. The platforms themselves, the ahu, represent another impressive feat of construction. These are carefully built stone platforms, sometimes hundreds of feet long, constructed with precisely fitted stones that would make any stonemason proud. The largest ahu, Tongariki, measures about 660 feet long and once held 15 moai. These platforms weren't just bases for statues, they served as ceremonial spaces, burial sites, and astronomical observation points. The entire complex of moai and ahu represents a massive investment of labour, resources, and social organisation. This wasn't a casual project. This was the central cultural and religious focus of an entire society for centuries. So why did they do it? The most widely accepted theory is that the moai represented deified ancestors and were believed to protect and bring prosperity to the clans that erected them. Each moai was associated with a specific lineage and was thought to channel mana from the spiritual world to the physical world. Creating and erecting moai wasn't just art or architecture, it was a sacred duty and a way of ensuring your clan's success and status. The more moai you had, the more powerful and prestigious your clan was considered. This led to what some researchers have called moai competition, where different clans try to outdo each other by creating larger and more elaborate statues. Classic keeping up with the Joneses, except the Joneses are carving 30-foot stone giants. This competition might have contributed to the civilization's eventual collapse. Easter Island was never a resource-rich environment. It had limited fresh water, poor soil compared to other Pacific islands, and the native palm forests that once covered the island were gradually cut down, possibly to provide rollers and ropes for moving moai. As the population grew and moai production increased, the environmental pressure became unsustainable. By the time Europeans first arrived in 1722, the island's forests were gone. The population was a fraction of its peak, and moai construction had ceased. Many of the statues had been toppled, possibly during inter-clan conflicts as the social order broke down. The unfinished statues at the quarry remain as evidence of a society that pushed itself too hard in pursuit of monumental construction. The environmental collapse theory has been debated, with some researchers arguing that European contact, bringing diseases and slave raids, was the primary cause of the Rapa Nui civilization's decline. Others suggest a combination of environmental degradation, social upheaval, and external pressures all contributed. What's not debated is that something dramatic happened. A culture that had successfully established itself on one of Earth's most remote islands and created an impressive sculptural tradition essentially ceased to exist in its original form. The last moai was carved sometime in the 17th century, and the cultural knowledge of how to create and move them was almost lost entirely. Modern conservation efforts have restored many of the fallen moai to their original upright positions on their platforms. The most dramatic restoration was at Tongariki, where a 1960 tsunami had scattered the 15 moai and destroyed the platform. A Japanese company funded the restoration in the 1990s, and now the statues stand again in a line, facing inland, recreating the view that would have greeted Rapa Nui people centuries ago. It's both inspiring and melancholy. Inspiring because we can see what these monuments looked like in their original context. Melancholy because we're essentially recreating something that a living culture should have been able to maintain if not for the various disasters that befell them. The Rapa Nui people still exist, of course. The island has a current population of about 8,000, many of whom are descendants of the original Polynesian settlers. There's been a cultural revival in recent decades, with renewed interest in traditional language, customs, and arts. But the knowledge of moai construction techniques had to be partially reconstructed through archaeological research and experimentation rather than being passed down through unbroken tradition, which is a significant cultural loss. It's like having to learn your own history by reading archaeology papers about your ancestors. What makes the Moai particularly impressive is that they represent the achievements of a small, isolated population working with limited resources. This wasn't an empire with vast territories and millions of subjects to draw labour from. Easter Island's population probably never exceeded 15,000 people at its peak and might have been considerably smaller. And yet with that limited population, without metal tools, without draft animals, without the wheel, and without any contact with other civilizations for centuries, they created nearly 900 stone monuments, many of which they successfully transported, miles from the quarry and erected on platforms. The level of social organisation, technical skill and sheer determination required is staggering. The Moai stand today as both an achievement and a warning. An achievement because they demonstrate what humans can accomplish through cooperation, skill and dedication to a shared cultural vision. A warning because they also show what can happen when societies become too focused on monumental projects without considering environmental sustainability and resource management. The unfinished statues at Rano Raraku Quarry are particularly poignant, frozen evidence of ambitions that exceeded capacity, of a civilization that kept pushing for bigger and better monuments until there were no resources left to continue. They're beautiful and tragic in equal measure, which is probably the most fitting way to remember them. After talking about civilizations that collapsed under the weight of their own ambitions, let's discuss something that might suggest ancient people were way more technologically advanced than we give them credit for. I'm talking about the Baghdad battery, a collection of clay jars from ancient Mesopotamia that might, emphasis on might, be evidence that people living 2,000 years ago had figured out how to generate electricity. Or they're just pottery for storing scrolls and we're all reading way too much into the fact that they accidentally created a primitive battery. Depending on which archaeologist you ask, these artifacts are either proof of lost ancient technology or the most overhyped storage containers in history. There's no middle ground on this one. The objects in question were discovered in 1936 near Baghdad, Iraq, during excavations of a Parthian settlement. The Parthian Empire, for those unfamiliar, was a major power in the region from about 247 BC to 224 AD, and they're mostly remembered for being really good at horse archery and really annoying to the Romans. What they're not typically remembered for is pioneering electrical technology, which is why the discovery of these particular artifacts caused such a stir. We're talking about terracotta jars, about 5 inches tall, containing a copper cylinder with an iron rod suspended inside it. The copper cylinder is sealed at the bottom with asphalt, and the iron rod doesn't touch the copper. It's held in place by another asphalt plug at the top. This configuration is basically identical to a modern voltaic cell, which is the fancy chemistry term for a battery. Here's where it gets interesting. If you fill one of these jars with an acidic solution, vinegar, lemon juice, basically anything with a pH below 7, you get an electrical current. Not a huge current, we're talking about maybe a volt or two, but that's still electricity generated by a 2,000-year-old clay pot. Modern replicas of the Baghdad battery have successfully produced electrical current, powered small lights, and even delivered mild electric shocks. So we know for certain that these objects can function as batteries. What we don't know for certain is whether that's what they were actually designed to do, or if we've just discovered the world's oldest example of accidentally inventing something useful. The theory that these were intentional batteries was popularized by Wilhelm Koenig, a German archaeologist who examined the objects and proposed they were used for electroplating, coating objects with a thin layer of gold or silver using electrical current. This would explain some of the remarkably fine gold-plated jewellery found from the same period. Electroplating requires a steady electrical current, and while the Baghdad battery wouldn't win any awards for efficiency, it could theoretically do the job if you had enough patience and several dozen jars working together. The ancient goldsmiths might have figured out that these strange jars could help them achieve coating effects they couldn't get through mechanical means like hammering or mercury gilding, which would be genuinely impressive and would mean that electrochemistry is about 1,800 years older than we thought. The medical theory is even more intriguing and slightly horrifying. Some researchers have suggested the batteries were used for pain relief through electrical stimulation, basically ancient electroshock therapy. There are references in ancient texts to using electric fish for treating ailments, so the concept of medical electricity wasn't completely unknown in the ancient world. Maybe some enterprising Parthian physician noticed that touching the iron rod and copper cylinder, while the jar was filled with vinegar, produced a tingling sensation, thought, "I bet this could cure headaches," and started prescribing battery therapy. To patients. The ancient world was wild when it came to medical treatments. If they were willing to drill holes in skulls to release evil spirits, shocking people with clay jars seems relatively tame. But here's the problem with both of these theories. We have absolutely no written records describing the use of these jars as batteries. Not a single ancient text mentions electroplating techniques using electrical current. No medical papyri describe battery-powered treatments. No instruction manuals titled "How to Generate Electricity Using Common Household Items, a Mesopotamian Guide." Which is weird, right? If you'd figured out how to harness electricity 2,000 years before everyone else, you'd think someone would write it down. The Mesopotamians were obsessive record keepers. They wrote down everything from astronomical observations to beer recipes. But apparently, hey, we invented batteries didn't make the cut for their cuneiform tablets. The skeptical explanation is considerably less exciting. These were just jars for storing scrolls or other documents. The copper cylinder would protect papyrus or parchment from insects and moisture, and the iron rod might have been used to roll or support the scrolls inside. The fact that this configuration can generate electricity when filled with acidic liquid is just a happy accident of chemistry that the ancient manufacturers never discovered or cared about. It's like how a potato can power a small clock if you stick the right metals into it, but that doesn't mean ancient farmers were using their vegetable gardens as power plants. Sometimes things can do stuff they weren't designed to do. Modern analysis of the artifacts hasn't definitively settled the debate. Some of the jars show evidence of corrosion patterns consistent with having contained acidic liquids, which would support the battery theory. Others appear to have bitumen residue and other materials that suggest they were used for storage. It's entirely possible that different jars were used for different purposes, or that someone discovered the electrical properties by accident while using them for storage and then repurposed some for experimentation. Ancient people weren't a monolith. They had just as much capacity for innovation, experimentation, and creative reuse of materials as we do. What's particularly frustrating is that many of the original Baghdad battery artifacts were lost or destroyed during the Iraq War when the National Museum of Iraq was looted in 2003. We're left with photographs, descriptions, and a few surviving examples, but a significant portion of the physical evidence is just gone. It's like losing the only copies of crucial experimental data because someone decided to rob the lab. Archaeological sites and museums in Iraq suffered tremendous damage during the conflict, and the Baghdad battery collection was just one casualty among thousands of irreplaceable artifacts. So we're trying to solve a historical mystery with incomplete evidence and a lot of educated guessing. If the Baghdad battery really was an intentional electrical device, it raises some profound questions about what other knowledge ancient civilizations possessed that we've lost. The Parthians were sophisticated metallurgists. They knew how to work with copper, iron, gold, and silver. They had advanced chemistry knowledge for creating dyes, medicines, and materials. They were excellent engineers who built impressive irrigation systems and architectural structures. Is it really that far-fetched to think they might have stumbled onto electrochemistry? Humans have been observing static electricity for millennia. The ancient Greeks noticed that rubbing amber could attract light objects, which is literally where we get the word electricity from the Greek word for amber. The jump from rubbing things creates mysterious attraction force to certain material combinations in liquid create mysterious tingling force isn't actually that huge. The other possibility that nobody likes to talk about is that we might be fundamentally misunderstanding ancient technology by applying modern categories to it. Maybe the Parthians did discover electrical properties of these jars but conceptualized it completely differently than we do. They might have thought it was a magical property, a divine gift, or some kind of spiritual energy rather than a physical phenomenon. Their battery might have been a religious object used in ceremonies, where the electrical sensation was interpreted as contact with the divine. We're looking for evidence of ancient electrical engineering when what actually existed might have been ancient electrical mysticism. The technology is the same, only the framework for understanding it differs. What we can say for certain is that the Baghdad battery demonstrates that ancient people had the materials and basic understanding necessary to create electrical current, whether they knew it or not. The components required, copper, iron, and an acidic electrolyte, were all available to ancient civilizations. The configuration that produces electricity isn't particularly complex or requiring advanced theoretical knowledge. Someone just needs to put these materials together in the right arrangement and notice the effect. Whether the Parthians actually did this intentionally, or whether we're seeing patterns that don't exist, is still up for debate. But the possibility that they knew about electricity, even if they didn't understand it the way we do, remains tantalizingly open. If ancient batteries weren't mysterious enough for you, let's talk about rocks that apparently decided at some point that sitting still was boring, and they'd rather go for a stroll across the desert. Welcome to Death Valley's racetrack playa, where for decades stones weighing up to 700 pounds have been sliding across a perfectly flat dry lake bed, leaving long tracks in the mud behind them, and absolutely nobody could figure out how. It's like someone set up the world's slowest, most confusing drag race, and forgot to tell anyone what the rules were. The racetrack playa is a dry lake bed in Death Valley National Park, California, already one of the hottest, driest, most inhospitable places in North America, because apparently regular desert wasn't challenging enough. The playa is about 2.8 miles long and perfectly flat, like nature decided to create an ideal testing ground for mysterious rock movement. Scattered across this flat surface are dozens of rocks, ranging from small pebbles to boulders weighing several hundred pounds, and many of them have distinct trails behind them in the dried mud. Some trails are straight, some are curved, some zigzag around like the rock was drunk. The tracks can be hundreds of feet long, and they clearly show that the rocks have moved significant distances. The only problem, nobody ever saw them move. The mystery was first documented in the early 1900s, and it baffled geologists, park rangers and tourists for over a century. People would visit the racetrack playa, see rocks with obvious tracks behind them, and immediately start coming up with theories. Magnetic fields pulling the rocks around, seismic activity causing vibrations that moved them, dust devils or whirlwinds picking them up and relocating them, pranksters sneaking out at night to push rocks around for fun, which seems like the worst possible way to spend your free time, but hey, people have done weirder things. And of course, aliens, because at this point if something is unexplained, someone will blame aliens. Maybe the rocks were alien vehicles, maybe aliens were bored and decided to mess with geologists. The theories got progressively more creative as the mystery remained unsolved. What made the phenomenon so frustrating is that it seemed like it should be easy to solve. Just set up cameras, watch the rocks, and document what makes them move. Except it turns out rocks don't move that often, and when they do, the conditions have to be exactly right. You can't just sit there with a camera for a few days and expect to catch them in action. The rocks might move once every few years, or only during specific weather conditions, or possibly only when nobody's looking because they're shy. Early attempts to film the phenomenon failed repeatedly. Researchers would set up time-lapse cameras, wait for weeks or months, and come back to find that nothing had happened. Or the cameras had malfunctioned. Or the cameras had successfully recorded nothing interesting for 10,000 frames straight. The breakthrough finally came in 2014, when a team of researchers led by Richard Norris from the Scripps Institution of Oceanography managed to capture the rocks in motion, using GPS-equipped stones and time-lapse photography. And the answer turned out to be simultaneously completely logical and slightly disappointing. The rocks move when a rare combination of conditions occurs. Rain creates a thin layer of water on the playa surface. Cold temperatures overnight cause that water to freeze into thin sheets of ice. The ice starts to break up and melt as the sun rises, and then wind pushes the floating ice sheets, which in turn push the rocks across the slippery mud surface. The rocks aren't defying physics or being moved by mysterious forces. They're essentially surfing on ice rafts being pushed by wind. Mystery solved. Everyone go home. Except not entirely solved, because as with all good mysteries, explaining the basic mechanism just raises more questions. For instance, why do some rocks move while others nearby don't? The rocks aren't evenly distributed in their movement. You'll find clusters where several rocks have moved, right next to areas where rocks haven't budged in decades. If it's just ice and wind, shouldn't all rocks in the same area move together? The researchers suggest it depends on factors like rock size, shape, weight, and how well the ice forms around each particular rock. Some rocks might be too heavy for the ice sheets to push. Some might be shaped in ways that create more resistance. Some might just be in spots where the ice doesn't form as effectively. The ice sheet explanation also requires very specific conditions that only occur rarely. You need enough rain to create a shallow lake, which is uncommon in Death Valley. You need temperatures to drop below freezing at night, which happens but isn't constant. You need the ice to form in thin, large sheets rather than thick chunks. You need wind at exactly the right time when the ice is breaking up but still strong enough to push the ice rafts, and all of these conditions need to happen in sequence. No wonder nobody caught it on camera for 100 years. The actual moving event is incredibly rare and requires a perfect storm of weather conditions that might only align once every few years or even decades. What's particularly interesting is that the rocks don't all move in the same direction. Some trails are parallel, suggesting those rocks moved during the same event. But others cross each other at angles, showing they moved at different times when the wind was blowing from different directions. Some trails show the rock changing direction mid-journey, which the researchers explain as the wind shifting during the moving event. One rock might start sliding northeast, then the wind changes and it curves around to slide southwest, creating those weird serpentine tracks that look like the rock was navigating an obstacle course. The heaviest rocks present their own puzzle. The GPS monitoring showed that even rocks weighing 60 or 70 pounds can be moved by the ice raft mechanism. But there are rocks on the playa weighing several hundred pounds, and while they also have tracks, we still haven't definitively captured them moving. Are they moved by the same ice sheet process but require even rarer conditions with thicker ice and stronger winds? Or is there another mechanism at work for the heavier stones? The researchers are fairly confident it's the same process, just requiring more extreme conditions, but until someone actually records a 700-pound boulder sliding across the playa on an ice raft, there's still an element of educated guessing involved. Before the ice raft theory was confirmed, some creative explanations were proposed. One popular idea was that the rocks were moved by strong winds alone. Death Valley can get some serious wind events. But testing showed that even hurricane-force winds couldn't slide a 700-pound rock across dry ground. The friction is just too high. You'd need winds strong enough to pick up cars before you could move the heaviest rocks through wind force alone. Another theory involved the ground becoming slippery with a mud-clay mixture during rain, allowing the rocks to slide more easily. This was closer to the truth, but still couldn't explain the logistics of rocks weighing hundreds of pounds sliding uphill slightly or changing directions. The magnetic field theory was particularly persistent despite having zero supporting evidence. The idea was that the rocks contained enough ferrous material that they were being pulled by magnetic anomalies in the ground. This sounded scientific-ish enough to be taken seriously by people who hadn't thought it through. The problem? Basic testing shows the rocks aren't particularly magnetic. The playa doesn't have unusual magnetic properties, and magnetic forces don't work that way anyway. Magnetism doesn't make things slide slowly across surfaces leaving muddy tracks. It either pulls them, or it doesn't. But the theory persisted because it sounded like a reasonable explanation if you didn't examine it too closely. What I love about this mystery is that the solution was actually proposed decades before it was confirmed. As early as the 1950s, some geologists suggested that ice might be involved in moving the rocks. They just couldn't prove it because capturing the rare conditions on camera wasn't feasible with the technology available at the time. So you had researchers in the 1950s saying it's probably ice. Everyone else saying, well, we can't prove that, so it must be mysterious. And then 60 years later, we finally get the technology to confirm, yep, it was ice all along. Sometimes, scientific progress is less about brilliant new insights and more about finally getting the tools to prove what people already suspected. The moving stones have become something of a tourist attraction, with people visiting the racetrack playa specifically to see the tracks and rocks. This has led to some conservation concerns because naturally some visitors can't resist the urge to touch or move the rocks themselves, either out of curiosity or because they think it's funny to create fake tracks. Park rangers have to regularly remind people that interfering with the rocks ruins the natural phenomenon and makes it harder for researchers to study. It's the classic problem of scientific sites becoming popular. The attention helps with funding and awareness, but it also increases the risk of damage from well-meaning but misguided tourists who want to leave their mark. Despite the mystery being solved, there's still active research happening at Racetrack Playa. Scientists are continuing to monitor rock movement to better understand the frequency of events, the specific conditions required, and the mechanics of how different rock sizes and shapes interact with the ice rafts. There's also interest in using the playa as a test site for understanding similar geological processes in other locations. The basic ice raft mechanism might explain mysterious rock movements in other dry lake beds around the world, or even help us understand geological processes on other planets where similar conditions might exist. The moving stones also serve as a reminder of how nature can create phenomena that look impossible but actually have relatively mundane explanations. We see rocks with long tracks behind them, and our brains immediately jump to exotic causes: magnetism, seismic activity, supernatural forces, because surely something that looks that mysterious must have a mysterious cause. But sometimes the explanation is just ice and wind under specific rare conditions, which is both more and less interesting than the alternatives. More interesting because it demonstrates how complex natural systems can create unexpected results from simple components. Less interesting because it's not aliens or magnetic anomalies or rocks that gained sentience and decided to migrate across the desert. What makes the Death Valley moving stones particularly satisfying as a mystery is that we actually got a resolution. So many of the mysteries we've covered in this video remain unsolved. We still don't know how they moved the Baalbek stones, we can't read the Voynich manuscript, we're still arguing about whether Yonaguni is natural or artificial. But the moving stones, we figured that one out, we documented it, we understand the mechanism, we can even predict roughly when conditions might be right for rocks to move again. It's a rare victory in the endless battle between human curiosity and nature's tendency to be weird and confusing. Sometimes science actually wins, and we get to close the book on a mystery with "case solved" stamped on the cover. Those moments are worth celebrating, even if the solution isn't as exciting as aliens or magic.